us use the area model to multiply polynomials. Hi, welcome back. In the previous video, we were able to already solve the product of each of these expressions when multiplied by each other. So you have here the result for number 1, 2, 3, 4, and 5. As for this video is concerned, let's try to use another method we also call as area model to see whether we could come up with the same result. By the way, when you talk about mathematics, there are many ways to solve a problem. And if you're just going to use the correct mathematical procedures, whatever your steps are or techniques, that's already okay with me. Let me show to you how this area model is done. Area model follows the concept of similar to your lattice multiplication or your multiplication table, wherein you are going to place here terms, 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 and terms. And the terms that will be placed inside these grids are the product when we multiply these terms here. Let us start with number 1. In number 1, we have a monomial 2x, and let us place 2x here, as this is actually the area with one uh, grid only. As for the trinomial, let us place each of the term in separate grids. And to do that, we will have here the first term x squared. To do this area model, I am encouraging you to use to take the operations separating the terms as the sign of the next term. So the plus 3x will become positive 3x, and the negative 1 or minus 1 will become negative 1. This is how we place these terms here. And then let's do it step by step. First, to get this part here, let us multiply 2x times x squared. Just like in your usual multiplication table, okay, 2 times 1, you will have 2. And you have here x. Still remember the multiplication law of exponents. We are to add the exponents here. 1 plus 2. That's for this grid. For this next grid, multiply 2x to this item here. 2 times 3, you have 6. And then you have x, you have 1 plus 1. And finally, for the last grid, you have 2 times negative 1, you have negative 2, and you have here x. These are the products for each of the term using this area model, or also known as lattice multiplication. The final result here is just by combining all of these terms by separating addition, as just what we have done in the previous video. So you have 2x, 1 plus 2 cubed. Separate it by a plus sign to the next term, 6x, 1 plus 1, 2, and plus sign here, negative 2x. The final step is just simply remove the grouping symbol for the last term. So you have here 2x cubed plus 6x squared. You have here minus 2x. And this should be the result for number 1. Let us see if we do have the same answer in as of the previous video that wherein we use the mathematical algebraic formulation. You have here the result, 2x cubed, correct, plus 6x squared, correct, minus 2x, also correct. So as we can see, for number 1, with the use of the previous method and the area model, we have the same result. But then again, even if it's an area model, you're still using the proper way to multiply, add, and then subtract probably later on polynomials. Let's proceed to number 2, and let's see if the result will still be 4w squared minus 15w minus 4. To do that here, let me cover this first. We are going to place here the terms for any of the two binomials. But let's just write the first term in this vertically so that it will be the same thing as what we did in number 1. So we have here w, sorry, and the minus 4 again will be taken charge. or the minus will be taken as a sign of the next term, which is 4. So let's try to multiply this using the area model. We have, of course, 1 times 4 is 4. And you have your W, add the exponents 1 plus 1. You could decide which next grid you're going to solve next. It's either here or here. It doesn't matter because later on we are going to separate all of the products by addition. And addition is, as you already know, commutative. We could start from here. Negative 4 times 4 is negative 16W. And then we have here W times 1 is positive 1W, or just simply W. That's already okay. Finally, negative 1 times, I mean, negative 4 times 1 is negative 4. With this result, let us try to separate all of the terms by addition. So we start with this 4W, 1 plus 1 is already squared. I could have it here. All right, let me write it here first. Plus, separate by a plus, negative 16W. And you have here plus 1W or simply W, and plus again parentheses for negative 4. And then see if there are things that could be combined. I'm talking specifically with these two terms. You have 4W squared. You have the same literal coefficient W, so proceed with combining the numerical coefficients. 16 plus 1, I mean negative 16 plus 1 is negative 15W. And definitely you have plus negative 4. And then you will have here 4W squared. Remove the grouping symbol, minus 15W, and then minus 4. Looking at the result in the previous step, all right, you have 4W squared, that's here, minus 15W, and minus 4. It's still correct using this area model. Notice the difference in our steps. The only difference, one of the difference I would like to highlight is this. Even if here, using the FOIL method, we have 1W first, and then the I will be negative 16. They are separate by addition. And in here, even if we started with negative 16 and later with W or 1W, still separated by plus sign, they will still yield the same result, as this is the continuation of the idea that the addition is commutative. Let's proceed to number 3. Let me move this item a little bit closer here, and let's find out if the result will be matching this result here as y squared minus 100. So we have here y minus 10. We have y plus 10. Y times y is y 1 plus 1. Here you have y times positive 10, as you have positive 10y. Negative 10 times y, this vertical item here, is negative 10y. And finally, you have the result for negative 10 times positive 10 is you have negative 100. The result for these grids can be combined into one expression, separating by addition. You have y, 1 plus 1 is 2. Let's start with this, plus negative 10y, plus this one, positive 10y, plus you have negative 100. That's 100. And then because of this, negative 10 plus 10 is 0. Just like this here, though they were just interchanged as 10 plus negative 10, you don't need to write 0y. So it would become y squared. Or if you would like to, okay, let us write this if you want to, 0y, and you have here plus negative 100. I'm just writing this for emphasis that even if you have 0y, the operation between 0 and y is multiplication. And when you multiply any expression, coefficient, or term with 0, this will become 0 itself. Finally, the final result is y squared. Let me remove this little bit here for no confusion. Y squared and then remove grouping symbol here, minus 100. See, it has the same result as the FOIL method. So it's now up to you which is actually easier for you to apply or use. Just don't forget the correct mathematical procedures. We still have two items here. For number four, as discussed in the previous video, this is actually the condensed form of writing two binomials of 3m plus n multiplied to be by each other. Okay, so 3m plus n times 3m plus n. And we could place here 3m and then plus n, and here 3m, another plus n. The area model allows to multiply grids per grid. So 3 times 3, you have 9. M, same base. So you have 1 plus 1. Here, you have 3 times 1 is 3. And since they are of different bases, do not add exponents. You still have m and n. Do not have mn squared, okay? It's just m and n. That is also true with the product here. Just simply arranging them 3 m n as well. And then n plus times n rather, you have n squared. Here, oh, I actually use now the colors green. So let me use another color to separate this next step. You have 9m, that's squared, plus 3mn. Any of the two, they are just the same. So they could be interchanged, 3mn. And then finally, n squared. We have the same literal coefficients mn. We could combine the second and the third term. 9m squared plus 3 plus 3, 6mn plus, sorry, that's n, plus n squared. We can no longer combine any of the three because they are of different little coefficients. In addition and subtraction, we cannot do that. So they stay as they are. Look at the result. 9m squared plus 6m plus n squared. Here, 9m squared plus 6m plus n squared. In number five, we still have a binomial to a trinomial. Now, if you would like to review the previous video, this one, this very lengthy process could be, I'm not saying to all, but could be for some of us very difficult and confusing to see because here we are distributing each term to all the terms of the second group. We could also use this a much arranged process, but then again, don't forget what are the correct mathematical procedures. So you have here a, and we have here plus 5. For the top, we have three terms, a squared. The negative 3a should be here, and you have here plus 1. Okay? And this one, you have here a times a squared, so you have a 1 plus 2. I am starting with these terms here. Next, again, we have 1 here. 1 times negative 3 is negative 3. And then you have a 1 plus 1. And finally, a times 1 is positive a or 1a, if you would like to. Next, 5 times a squared is 5a squared. 5 times negative 3 is negative 15a. 5 times 1 is 5. The good thing about this area model or lattice multiplication is, again, if you're in confused with this, especially when adding terms, you could see this in diagonal portion. I'm talking about this terms here. In diagonal from top right to bottom left, you would see terms with the same coefficient because this 1 plus 1 is a squared and you have a and a. You could easily add them up so that there would be no confusions. Therefore, the result here will just be simply a 1 plus 3 cubed. Then you add this diagonally. 5 minus 3 is positive 2a squared. And you have negative 15 plus 1 is negative 14a. And you have here the remaining term, which is 5. Take note, we have the same result here. A squared, a cube rather, plus 2a squared minus 14a plus 5. This is the unique way of understanding the lattice diagram or area model. This is also true at the top here. Looking at this diagonal portion here, these are the terms actually that you are adding here. Same as to dito. This, these are the terms here, and even in number two. Right? That's the unique way for the area model, or also known as the lattice multiplication. But still, if you don't like that, you would like to just simply combine everything, so you can always do this. You have a, let me move this a little bit here. This green area is the result of the adding the similar terms diagonally. But if you don't like direct adding and you just like to use the same process here, you can still do that. A cubed for the first term. Let me write it here. Plus 5a squared plus negative 3a. 1 plus 1 is 2 plus, let's start with this, negative 15a with that plus a, and you have here plus 5. We are writing all of the results here, separating them by addition. And then finally, you have here a cube. Similar terms, 5 plus negative 3 is positive 2, a squared. Same similar terms, negative 15 plus 1, again there's 1 here, is plus negative 14a. And finally for the last term, plus 5. Remove this grouping symbol here. Your final answer should be a cube plus 2a squared. Or removing of grouping symbol, minus 14a plus 5. Same result as this, and more importantly, same result as this method in the previous video. So the content again for this video is another method, also known as the area model or the lattice multiplication. So see, the results are just the same. And if these methods could be applied later on, if you would like to, in our next activities. See ya.